Next, convolution theorem or faulting theorem. So first we are going to define convolution. Convolution of two integral function f of x and g of x over the interval minus infinite to plus infinite is defined by, that is a function h of x that is equal to f star g, that is f convolution g of x, that is equal to 1 by root of 2 pi integral minus infinite to plus infinite f of u g of x minus u du. It is also called faulting of f of x and g of x. So now we are going to see the convolution theorem or faulting theorem of Fourier transform. So if Fourier transform of capital F of x and capital F of g of x are the Fourier transform of the function f of x and g of x respectively, then the Fourier transform of the convolution of f of x and g of x is the product of their Fourier transform. That is, Fourier transform of convolution of f and g, that is f of x star g of x, which is equal to product of their Fourier transform. Fourier transform of f of x into Fourier transform of g of x. We will see the proof. We know that Fourier transform of f of x and g of x is given by, so that is f of capital F of x is equal to 1 by root of 2 pi integral minus infinite to plus infinite f of x e power I px dx, and f of g of x is equal to 1 by root 2 pi integral minus infinite to plus infinite g of x e power I px dx. That is equation number 1. We know f and g, convolution of f and g, that is f of x star g of x is equal to 1 by root 2 pi integral minus infinite to plus infinite f of u g of x minus u du. That is equation number 2. Now Fourier transform of convolution of f and g, which is equal to 1 by root 2 pi integral minus infinite to plus infinite. So f of x star g of x e power I px dx, right? That is equal to 1 by root 2 pi integral minus infinite to plus infinite. So we are going to use 2, right? Equation 2. That is 1 by root 2 pi integral minus infinite to plus infinite f of u g of x minus u du into e power I px dx, right? So that is equal to, taking 1 by root 2 pi outside, already you are having 1 by root 2 pi. So 1 by root 2 pi into 1 by root 2 pi, that is 1 by 2 pi, correct? Double integral, right? Minus infinite to plus infinite f of u g of x minus u du e power I px dx, right? Now we are going to group this into two integrals. So first one, 1 by 2 pi integral minus infinite to plus infinite, we are taking f of u outside. So f of u from one integral, right? F of u, then integral minus infinite to plus infinite g of x minus u e power I px dx, then du. Now in the inside integral, that is the integral with g of x minus u, we are multiplying e power I pu and e power minus I pu, because we know e power 0 1, 0 can be written as I pu minus I pu. So we can e power I pu into e power minus I pu. That is what, right? We are multiplying with 1. So there will be no change, right? So that is equal to 1 by 2 pi integral minus infinite to plus infinite f of u integral minus infinite to plus infinite g of x minus u. Now we are grouping e power I px and e power minus I pu. E power I px and e power minus I pu, grouping the powers I px minus I pu. Then balance we are having into e power I pu. Then x dx can be written as derivative of x minus u. With respect to x, u is a constant. So d of x minus u is nothing but d of x, right? So that is equal to 1 by 2 pi integral minus infinite to plus infinite f of u integral minus infinite to plus infinite g of x minus u e power that is ip is common, so take it outside, e power ip x minus u into e power I pu d of x minus u du, that is equal to 1 by 2 pi integral minus infinite to plus infinity f of u. So with respect to inside integral, that is derivative of, that is with respect to d of x, right, x minus u. With respect to that integral, e power I pu is a constant, take it outside from the inner integral, right, e power I pu integral minus infinite to plus infinite g of x minus u e power I p x minus u d of x minus u into du. So again we are going to split 1 by 2 pi into two terms, that is 1 by root 2 pi into 1 by root 2 pi integral minus infinite to plus infinite f of u e power I pu integral minus infinite to plus infinite g of x minus u e power I p x minus u d of x minus u d. Because we are going to use Fourier transform definition, right, that is why, right. So keeping 1 by root 2 pi, one of the 1 by root 2 pi outside, 1 by root 2 pi integral minus infinite to plus infinite f of u e power I pu, another 1 by root 2 pi we are taking inside, right, 1 by root 2 pi integral minus infinite to plus infinite, take x minus u is equal to y, so g of y e power I p y dy into du, right. So that is equal to 1 by root 2 pi integral minus infinite to plus infinite f of u e power I pu 1 by root 2 pi integral minus infinite to plus infinite g of x e power I px dx. Changing the variable. We know integral f of t is equal to integral f of x, which is equal to integral f of y. So whatever it is, you can change the variable, the value of the integral will not change, right. So using that idea, so integral minus infinite to plus infinite, instead of y I am putting the variable x, g of x e power I px dx, right. That is equal to 1 by root 2 pi integral minus infinite to plus infinite f of u e power I pu. See, 1 by root 2 pi integral minus infinite to plus infinite g of x e power I px dx is nothing but Fourier transform of g of x from 1, equation number 1, you can write from the definition of Fourier transformation, right, which is equal to 1 by root 2 pi integral minus infinite to plus infinite f of u e power I pu du into Fourier transformation of g of x. So 1 by root 2 pi integral minus infinite to plus infinite, again we are changing the variable, instead of u you put x, f of x e power I px dx. That is nothing but Fourier transformation of f of x is the first one, right. So Fourier transform of f of x into Fourier transformation of g of x. Therefore Fourier transformation of convolution of f and g, which is equal to Fourier transform of f of x into Fourier transform of g of x, which is to be proved. Now Fourier transformation of f of x convolution we are taking now. So Fourier transformation of f of x convolution, Fourier transformation of g of x is equal to Fourier transformation of f of x into g of x. That is also true, right. Next note, f star of x is the complex conjugate of f of x. Then Fourier transformation of f star of x is equal to f bar of minus p, right. Thanks.